Now let's see a concrete example of how can we calculate the n-step transition probabilities. So in this example, there are only 2 colas in the world. And then given the last purchase of a person is cola 1, there is a chance of 90% that her next purchase will be cola 1 as well. So by next purchase, it means that here we're talking about just one step transition. So based on this information, you should be able to define the transition probability, which describe the transitioning from one state to the other state in just one step. Okay, so 90% chance this person will buy cola 1 again. However, if a person last purchased cola 2, there's an 80% chance that her next purchase will be cola 2 as well. So all this information may be described using this transition probability matrix. So remember that even though the problem only states this 90% and 80%, the sum of the row for each row on your matrix must equal 1. So you need to infer that, okay, if those who purchase cola 1, 90% of them will purchase cola 1 again, it means that the remaining 10% will change to cola 2. The same case with those who purchase cola 2 at this moment. If 80% of them purchase cola 2 again in the next purchase, it means that 20% of them change to cola 1. Now, if we look at the questions, the first question says 2 purchases from now. So we need to solve the 2-step probability. In the second question, it asks 3 purchases from now. So we need to solve the 3-step probability. So let's see how we can do that. So first, we're going to look at the 2-step probability. Because we're going to look at 2-step probabilities, what we need to do is simply multiplying the matrix P 2 times to obtain P squared. So P times P again. And then the question says the person is currently cola 2 purchaser. We'd like to know what is the probability she will purchase cola 1. Once you have this P squared matrix, you can just look at the row 2, column 1. So that is the answer, 34%. Second row, because now she is purchasing cola 2. First column, because we're going to look at what is the probability she will purchase cola 1, 2 purchases from now. So 2, 1. So you just need to look at the element 2, 1, row 2, column 1. So this multiplication may also be explained using the graph. So that row here shows that we are purchasing cola 2 at this moment, and then the next purchase can be cola 1 or cola 2. And then that column says that whatever we purchase at time 1, our final purchase must be cola 1. So that multiplication results in this number, 0.34 or 34%. The next question asks about 3-step probability. Since we've already had the 2-step probability from the previous slide, the P square, we just need to multiply that by P once more. So now we have P to the power of 3. And then same as before, we just need to look at the correct element. So it says currently cola 1 purchaser, so we're looking at the first row. What is the probability she will purchase cola 1 again, 3 purchases from now? So we look at the first column of the P to the power of 3 matrix. So first row, first column from the P to the power of 3 matrix. So now here's a question to check your understanding. So given the transition probability matrix P, so this is just one step, and then given this result on this table, So this is one step. The values are the same with the matrix here because it is one step transition. And then given 2 steps transition, 3 step, 4 step, up to 40 step transition. Now the question is, after a large number of purchases, for example 40 purchases or 40 step of transition, which one of these 2 statements is correct? I will give you the answer after the pause of the video, so you may have some time to really think about the answer. If we draw the result of this 40-step transition probabilities in terms of a matrix, we will see something like this. Which means that after a large number of purchases, like 40 purchases from now, regardless of the current purchase at time 0, this doesn't matter anymore. The probability of a person will purchase cola 1 is 0.67. The probability of that person will purchase cola 2 is 0.33. So now you can see that if it's just one step transition, what the person purchased at this moment really matters. Whether the person purchases cola 1 or cola 2, it really gives a significant impact on the probability of what the person will purchase next. So just one step next. However, if the steps is very large, like 40 purchases from now, what the person purchases at this moment doesn't matter anymore. So this is what we can see based on the result from this table.